Graph the following equations by hand. You must clearly graph or list 2 points on each graph. Indicate the asymptote with a dashed line, then list the information for each graph. Alright, so they basically want us to graph. This is a, notice it is a logarithm graph. So how do we graph logarithms? How does that work? Let me give you the game plan right over here. So to graph a log, it's base 3 of x minus 2. So the first thing is to know, in general, what does a log graph look like? It dives down on one side and then it grows slowly on the other side. By slowly, so it takes a dive on one side and grows slowly on the other. Or it can go reverse. So that's what logs do. Now the important point is that place where it dives. And how do you find the dive? It's the number right here. It's the opposite. Opposite of the number added or subtracted next to x is where the log dives down. It's where the log dives down. So that's where you start. So what do we have? In our case, that's x equals positive 2, the opposite of the negative 2. So at x equals positive 2, so right here, that's where we're going to have. So really, I should say the opposite number next to x is where there is a vertical asymptote. That's where there's a vertical asymptote. So at x equals positive, there's a vertical asymptote, and that's where the graph dives down. Now, beyond that, we need to plug in some points. So let's make a table. And plug in some points. Now, you can plug in any point you want, but the easiest point, we'll start with the vertical asymptote plus 1. So what was the vertical asymptote? X equals 2, right? That's right here where the vertical asymptote is. So go one higher than that. So start with the vertical asymptote. And in fact, you can even start, why don't we do this? Why don't we just start with the vertical asymptote? We already know about that. That's the vertical asymptote. So just add 1. Yeah, that'll make it like how we did the exponential graph easier for you to remember. So just add 1, right? Isn't that what we did back with the vertical asymptotes? We'd start with the point that was the horizontal asymptote for the exponential graphs. Now, just add, and then we add 1. So we just add 1 here to the point where the vertical asymptote is. So add 1. What do we get? Y will equal log base 3 of 3 minus 2 plus 4. So that'll equal log base 3 of 1 plus 4. Now, figure this out on your calculator. How? How so? Here's what you do. How do you figure out this part? Well, it's going to equal, you let the low part go low, so the log 3, goes to the bottom, and the log 1 on the top. So notice I turned it into 2 logs, right? It went from 1 log to 2 logs. That's called the change of base formula. I won't write down that name, but that's an important formula. I'm not proving right now that it's true. It is true, but now's not a good time to prove it. So, but that's what we're going to use. So when you have, and why do we do it? Well, because if you think about it, we can't do that log base 3 of 1 any other way. We don't have a log base 3 button on our calculator, right? We only have a regular log button, which means log base 10. So we can't do log base 3, so we have to turn it into 2 logs and then keep the plus 4 there also. So when you do that, you'll get 0 plus 4, which is just 4. This part you'll see on your calculator will become 0. So that's what we do. We're going to have to do this a lot for logs. Important that you know that. Let's do, so that's 1 point over 0, over 3. It's over 3 up 4, over 3 up 4. Boom. Right there is the log. Right there. Okay. So if we have the vertical asymptote, and then we have that. Now we're going to need we have the vertical asymptote, and we have that dot. Let's get one more point, because notice it said 2 points. So let's go for another point. How about if we go up to, let's say, 4? So now I'm going to plug in 4. Let me get rid of this stuff. So this will become, here, let me back up, get that out of our way. Okay, so y will equal log base 3 of 4 minus 2 plus 4. Hit the buttons on your calculator. You turn it into 2 logs again. This is 4 minus 2 is 2. So log 2 over log 3 plus 4. And I believe you're going to get some decimal thing. I'll do it on my calculator right now also. Log 2 divided by log 3 and then plus 4. I'm getting 4.6. It goes on and on. 4.6. Now over 4.6. That's about right there. The problem with that is it's fine. It's a dot. It's a valid dot, but it's going to be hard to locate on the graphing tool. So let's go up one more. Just keep going till you get a nice one that's whole numbers. So I'm going to go to 5 now. So log base 3 of 5 minus 2 plus 4, which is log base 3 of 3 plus 4. And so if you plug that into your calculator, remember you turn it into 2 logs. Well, that's clearly 1 plus 4, 5. So that's over 5 up 5. Right there. So there's 2 really clear dots. This is over 5 up 5, and the other one was right here. This point is over 3 up 4. Okay, and so you can see what the graph is. And the graph must be going through these dots. Remember how it looks, and then it must take a dive right there at that vertical asymptote line. So there it is. There's the graph for that one. Now, they want a couple of facts down here. They want the domain. What is the domain of a graph? The domain is the width. So the domain, here, I'll put it up here on the x-axis. The domain is the left edge to the right edge. How far left the graph goes, how far right. The width, like how wide is our red graph there? How far left does it go? Well, it goes to 2, but it doesn't quite touch 2. So that'd be a parenthesis at 2, not a bracket, right? It never touches 2, just a parenthesis. And then it goes, see this arrow up here? It's going to the right forever. So that's infinity. So the domain, the left edge, comma right, that's the left edge, comma right edge, is from 2 to infinity. The range is the same thing, but it's up and down. So the range is how far down, how far up, bottom, comma top. So the range is going to be bottom, comma top. How low does the graph go? It goes down forever. How high? Up and right forever. It's not going up very fast. It's slow growth. Remember I said log graphs always take a dive on one side and go up forever. Slow growth. right, grows slowly on the other side. But it is going up forever, so that's going to be negative infinity to infinity. That's the bottom comma top. And finally, the asymptote, well, that dotted line is right here at x equals 2. That's where the vertical asymptote is. So there we go. There's all the